Perfect. I think we're on. Uh, anyways, get some chat going, and we are live. Perfect. Absolutely. Hey everyone, welcome to the stream on the 6th of August 2024. What are we going to do today? So, I think in the previous streams, at some point, I handled how to set up FreeRTOS, I think so, and get it running. And I think in the previous one, if I'm not wrong, or the last one where we did FreeRTOS, we got FreeRTOS running and we got some hooks running, and we basically had the system running. However, we added FreeRTOS to an application that already had like an already existing application. This wasn't like something we're building from. We were not adding FreeRTOS to an application that as we're building from the beginning. We had some sort of defined functionality that we wanted to plant FreeRTOS on, and now that we have FreeRTOS running in our application, I think this should just run. If I could just hook up my hardware. If I could just hook up my hardware. Cool. If I could just hook up my hardware and do a run, start debugging. I think if I just yeah, if I just go to the terminal and we look at that and we do run, we'll see. Yeah, pause. Tick application, tick hook is being run and all of that. So let's stop. So FreeRTOS is running. However, I want us to look at our application and then now realize that let's look at our application. This is our main file. Amazing. Cool. Here's our main file. So we have a main file. We need to initialize things and get things going. And there's quite a bit of code in this application where we want to handle other things. Cool. So the first thing we need to do is to do all of this sysinit stuff that basically um, handles initializing the system. Okay. At the moment, as you can see, we have system initialization. Okay. System initialization. And then what we do after a little while is, I think, at the bottom here, we start the FreeRTOS scheduler. So what do I want to do? I want to move all of this functionality that is outside the application, the FreeRTOS scheduler into the FreeRTOS itself. So what does that mean? What does that entail? I'm still not sure about how which direction this stream will take, because we might sit down and do a lot of code, or we might actually discuss a lot, or it could be a combination of both. So pardon me as I go along. Cool. So what does that mean in FreeRTOS land? So we have a system sort of like grow online. Just need to just need to okay. Just a moment. Just a moment. Okay, cool. So let me see if I can get something. Sketchpad. Yeah, cool. Um, Turns out I think I've drawn on here before, so let's do a new one. No. Do a new one. No. Uh, okay. Yeah. Yeah. I don't know if these are mine, but cool. So what we basically have is, anyways, we can zoom in probably. Ah, cool. So what do we have? Maybe notepad. Why do we need a notepad if I'm inside a code editor? So let's just come up here and write some stuff and see what we need to do. So here's our application. Okay, our application. Functions in our application. So right now our application is rather simplistic. So we have we have a few things that we want to do. Okay, cool. So the few things that we want to do are number one, we have an accelerometer. Number one, accelerometer. And what do we want the accelerometer to do? Log out access values when a threshold is crossed. Okay. Number two, then we want time update every minute. Number three, we want temperature measurement every 2 minutes. At the moment, I think this is all we have. So let me drop statistics or remove delays. System need all of that stuff. So what did we have before? Yeah, set up hardware. And then you see setup SPA, right? Blah 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 blah. Okay. And then here what do we do? Configure team 7. We don't really need it for delays right now. We can use it for delays, but we don't need timer 7 for delays because timer 7 was used to delay was used to read should read. Let's look at should read. Was used to read the what's that? The temperature. So we can now we don't need timer 7 anymore because we can use FreeRTOS to build our non-blocking delay, and then this non-blocking delay can do basically what we want. Okay, cool. And then we obviously don't need the delay timer. All of these things we don't need now because FreeRTOS will handle timing for us. And what we want to do is put all of this functionality inside FreeRTOS. Cool. So this is the three functions that we have. This application will grow. Okay, but at the moment it's at a simple enough version that you can see how to add FreeRTOS to an existing application. And it could become more complex as we go along. So let's hook up some stuff. Let's do some stuff now that we know this is what we have right now at the moment. So we need to set up the way FreeRTOS works is you have something called a task, and a task in FreeRTOS is a function that never returns. And a task in FreeRTOS is basically a function that runs a function that runs in a infinite loop. If that's the best way I can say. So this function never returns. It runs in a yeah. This we'll get to it just now. I just want to get to task manager talk. Come on. Yeah. So each task, each task is a small program in its own right. It has an entry point and it will normally run forever in an infinite loop and does not exist. That does not exist. If you don't need a task anymore, you can delete the task. So the tasks should never get to a point where they can exit the function that they're building. So here's an example of a task. Look, void va task uh, takes some parameters. This is a variable, and then it runs in here. Okay, and this is the infinite loop. Okay, if we do ever get out of this infinite loop, the recommendation is to delete this task. Okay, so that the task does not get to the end. And additionally, tasks should not contain a return statement. If that makes any sense. Okay, cool. So we have all of that going. So we know what a task is, and we know we know what they do. So it's a function. It's a function that runs an infinite loop. Okay, and obviously then we can introduce things like priorities, things like um, things like priorities, things like time slicing, and things like task notification, messaging, sending one message from one task to another. We'll get that. But at the moment, we just want to look at the general like overview of how to like convert an existing application into FreeRTOS. Later, maybe the next stream, I'll do a deep dive on how to on what tasks are, how to define them, and how to use them. Maybe, yeah, that would be better. So today, let's look at how to do the hardware setup. Okay, so just the hardware setup, so that we can end up with um, a good function, a good structured C FreeRTOS program that wants to look. So yeah, and then 0.1 here we need to set up the hardware as we want. Okay. So if you remember, I did write a blog, which is, and I think it was a FreeRTOS Primer. Yeah, cool. So there was this naming convention, name when it's for reporting FreeRTOS function and variable names. So yeah, privately scoped functions are prefixed with the PRV prefix, denoting that they're local to the file that they're defined in. Okay, cool. So in here, what I want to do is to move all of this sysdig stuff, all of this stuff for setting up my hardware into a function that sets up the hardware so that my top level entry for the application looks simple and I know what is doing what. Okay, cool. So what do we do? What do we do? Mm, okay, cool. So let's define a void function. Let's let's I want to move these into after artist hooks. Okay. And then I want to move this into Control X. What I want to do is put these here. Okay. And run. Start debugging. Does that break my build? No, that does not break my build. Cool. So that's the first thing. We move the functions down there. Okay. Now, so now let us do all the hardware setup we need to do so that we don't need to so that we have a cleaner application that reads better. Okay, cool. So let's define, there's a function we need here. Uh, void PRV set up hardware. Okay, this takes a void. Okay, cool. And then we take this, I'll take this, and I want to go immediately after main. Immediately after main, and I want to do PRV setup hardware here. Okay, so in here, PRV setup hardware. Okay, cool. Does all the hardware set up for the application, including clock speed setup, driver initializations, mode init initialization. Okay, cool. So that's what this function does. Doesn't return anything and whatever. So cool. So let's look at what needs to be done when we are setting. What amount of hardware setup do we need to do? First of all, we have sysinit. Basically, this is where this should all go. All of this in sysinit should go into. Give me a moment. All of this in sysinit should go into PRV hardware setup. So this is ADC init, SPI read and write. Okay, cool. Relax. Okay. Okay. And then we can remove the sysinit function. And then we can go here. Wait, just give me one moment. Sysinit, and we want to remove, we want to do priv setup hardware. Cool. Okay. Set up our hardware. Okay. We need the timer initialization. We need a timer for doing delays. We don't need a timer delays right now because FreeRTOS comes with a delay manager. Cool. Configure Team 7. Team 7 is used in addition to the timer delay so that we can, the timer delay, Team 7 is used to periodically enable us to read the temperature every 2 minutes or every 2 minutes. Basically, what we do is we set a flag should read, and then the flag is only updated when Team 7's delay moves. So what we want to do is rather than using Team 7 for delay, we can now move all of these delays into FreeRTOS. So for now, we don't need it. Okay. Okay. We don't need timer init because we don't need the timer. We don't need configure Team 7 because we don't need that. Okay, cool. This is in main. That's fine. And then this is set up I squared C, set up the pins, set up all these things, and get I squared C running. Cool. Okay, so this is, let's move let us move all this setup to here into, okay, cool. So do we want to make an extra function for setting up hardware, for setting up a squared C? So let me look at this. Just a moment. Let me look at, do we need configure team7? No, because we don't need it. This is for delays. We don't need that. We're going to use FreeRTOS to do our delays. We don't need team7 handler. That's fine. I squared C handler, C event handler, error handler. This can stay. These can stay. We'll move them later. Okay. And then what do we need to do? So I would like to, in the hardware setup, SPI read and write, SPI read address, and the DC setup. And so this is set up, use SPI to set up accelerometer. Okay, and SPI setup. Okay, and then use I squared C to set up the, what is on I squared C, the real time clock. Okay, cool. So let's move all of this stuff that sets up. We need timer, delay timer, timer start, blah, 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 blah. We don't need a delay time. Delay timer, timer start, delay 20 milliseconds, do that, do that. No, we don't need this. Why did we delay 20 milliseconds here? Delay before reading this. It's okay. This is fine. So we don't need delay timer, we don't need timer start, we don't need all of that. I think that's gonna break some stuff. This is fine. We don't need it anymore. This whole stuff isn't needed anymore, but it's okay. This is all set. This is all going to be handled later. Blue LED set up blue LED using LED cases. Okay, cool. This is all. This can't stay. This can't stay. Should be in RTC task. Okay, cool. So set it up and whatever. Like this, all this hardware setup, all the what does this setup? Set up I squared C for set up ITC for RTC. Yeah, this can go in here. Okay, so that is all the setup hardware and stuff. This should be in RTC task. Okay, so let's move all of this. You see this? This sets up I squared C for the RTC. All the way to here. And this should all go into PRV setup hardware and accelerometer set up. Okay, cool. So what do we need to do here? So in here we need to and I2C init for RTC. Okay, relax, put you there. Yeah, let's put you at the top. Enable FPU, get the log out sys speed, and then list 3 setup, that's fine. ABC setup, that's okay. That's fine. That's fine. This is all fine. This is all fine. We don't need that. We don't need time update anymore because we won't be using time update anymore. ICRT error handlers and event handlers will be moved. Basically, all we need to do now is to set up blue LED using it. Okay, set up blue LED. Set up blue LED for heartbeat. Okay, so maybe we also have a heartbeat task. Maybe add a heartbeat task. 0.2 heartbeat task. Okay, cool, that's fine. Okay, so let's see. Should be in RTC task, start the scheduler, and should be in Excel task. Okay, cool. This is okay. This is fine. So we'll get to this. And yeah, our program is starting to look a little cleaner. Mm-hmm. We don't need this should read anymore, but we'll leave it. Configuring 7 also does not is not needed because we don't need it. Sys init is also not needed because we won't use it. Device ID can also go to the drivers, but it's fine for now. Okay, cool. So this is mostly a lot of code deleting. Okay. Once look, so how do I understand? How do I explain this? So once this is started, we have handed over control to FreeRTOS. Okay. The following code is unreachable and should be moved into specific tasks. Okay, cool. What if I run? What happens if I start debugging? Okay. What happens? Cool. So stop. Mm-mm. Mm. Yeah, that looks okay. That looks okay. I want it to go. Yeah. I want it to stop there. So run, start debugging. And clicking. Ah, perfect. So what we get everything we had in the first place. So we've moved all of our hardware setup. This isn't really like how do I say this? It is actually significant. Uh, I'm having so because it feels like we just deleted a function and redefined another function. Yes, that's all we did. We could have used sysinit for this, but for the purposes of moving to FreeRTOS, this is kind of what we need. And whenever you whenever you now go into a new application, so uh, some of the people watching this video will be people who have just joined our team at some place and they haven't used FreeRTOS before, and now they're going to use FreeRTOS in this new team setup that they're in. That's some of the people who are going to be watching this video. And part of the effort in this video is to show you how to do things the FreeRTOS way, but also show you how things are done the FreeRTOS way. The significance is if you're using this to jump onto a FreeRTOS application, then you can find the information. If you're using this to trans to translate your application from Baremetal to FreeRTOS, then you can also use this information and you can translate it in such a way that developers will later along down the line come and they will be able to down the line developers will be able to maintain your application because it is run the FreeRTOS way. Okay, so I kind of want to separate my streams here. So this is another part where I want to now the next stream involves a lot of task stuff where basically the next part of this involves translating all of the things that we have right now into tasks. But I would like to do that as a standalone stream by itself so that we have little concise pieces of information that can be used. Um, and hence I won't do it in this stream. Also, it's sunny outside and I want to go play, which is rare in winter in South Africa. Yeah. So, does anyone have any questions? Does anyone have any observations? I don't know if anyone is watching this. If you have any questions or any observations, leave some comments down below. Leave me any questions. Leave me any requests if you want me to explain something better. If you want me to show something better, uh, as you like, leave it in the comments and we'll see. Uh, what else? What else? What else was I gonna cover today? Just I was trying to see what I was gonna cover. If you want me to explain something better? If you want me to, okay, cool. So that's today's stream. This is part one where we translated our application from bare metal to FreeRTOS, and the first part we did is moving all our hardware setup to private setup hardware. Next time, we'll move all our periodic tasks into tasks and get those tasks running themselves, and we observe them. And then we'll see about maybe adding priorities or maybe some queues so that we can the future will define itself. But today we've done this, and at the present we've done this. Thank you so much for attending this stream. Let me know if you have any suggestions on how I can improve this. Let me know if you have any suggestions of some topics I can cover. We have some pretty heavy topics coming up, and yeah, it's been awesome. Cheers.